So we're diving deeper into dimensional analysis today, and we're going to be talking about converting unit rates. So we were using unit multipliers to make conversions. We're going to continue to do that, but now we're just going to apply it to a rate. So first thing we have to understand is, what is a rate? A rate is a comparison. And remember, when we're doing a comparison, normally we're dividing. Division, okay? A rate is a comparison of two different units. And let's talk about some of the rates that we deal with every day. I know one that I think about every day as I'm driving around Broward County is I need to be thinking about miles per hour. That's how fast we go, miles per hour, fast in our car. Maybe if we are riding in a rocket, we might be thinking about feet per second, or even crazier, miles per second. That's if you're going ridiculously fast. Maybe we might think about, I wrote it upside down, miles per gallon. We think about that when we're buying cars. We want to know how many miles per gallon of gas a car might get. Crazy enough, if you drive a fire truck, you want to know how many gallons per minute a fire truck could pump water. You want to think about that when you are filling your swimming pool, or if you are buying a new toilet at Home Depot, you want to know how many gallons per flush. So those are all rates. A rate is a comparison of two different units. Oh, just thought of another one. Price per pound. You think about that when you're buying meat or fish or seafood at the market. So those are all rates. A rate is a comparison of two different units. Very useful information. So once again, you need your calculator to do this because these numbers are going to get a little wild. And we're going to still use unit multipliers, and I want to see you using unit multipliers when you do your practice problems in your listening notebook. So get your calculator ready. We're going to need that. So let's see what we've got here. And remember, when we have a word problem, read all the way through it first, and then we'll go back and we'll pick out the useful information. Cheetahs are built to run faster than humans and most every other animal. They regularly clock speeds up to 60 miles per hour. At that rate, how many feet per second are they moving? So our first given rate is 60 miles per hour. And our unknown is we want to know the number of feet per second. So we're going from miles per hour to feet per second. So let's start setting up our problem. So 60 miles per hour. Every time you read that word per, that is going to be your big fat fraction bar. That's where you're going to be doing your division. So per means division. Not like a cat purring, but the word per, it's indicating division. So think about what we want to undo first. It's the same plan that we were using before. So here's from the previous video. Remember, plan first, consider what you want to cancel. Second, the new unit that you want needs to go on the top, and what you're canceling needs to go on the bottom. Well, this has multiple units, so we can't stick to that simplistic plan as it is written, but we've got to think about what do we want to get rid of first. So if we're going from miles to feet, why don't we get rid of miles first? So if we want to get rid of miles, we need, if miles is on the top, we need mile on the bottom. We're going to feet. So I've got my handy conversion factors index card here. 1 mile is 5,280 feet. So this is my first unit multiplier. So remember, a unit multiplier is equal to 1. This is equal to 1. So when we multiply by it, we're not changing the value. We're just renaming the fractions. That's all we're doing. Now we've got miles on the top, miles on the bottom. One's got to be on the top, one's got to be on the bottom in order to cancel. Now we've got feet per hour. Do we want feet per hour? No, we want feet per second. So the next thing we need to do is make hours cancel. So we need to know how many seconds are in an hour. Well, let's think about it. We'll use the calculator for just a minute. In 1 hour, there are 60 minutes. And in every one of those minutes, in every one of those 60 minutes, see if it'll focus on the calculator there. Now it will. In every one of those 60 minutes, there are 60 seconds. So 60 times 60 is 3,600. So there are 3,600 seconds in every hour. That's a conversion factor that we can use. You can write that on your index card if you like. So I'll write it on the bottom of mine right here. 1 hour is equal to 3,600 seconds, because we know that 1 hour is equal to 60 minutes. So this is our next conversion factor, our next unit multiplier. So remember, what do we want to get rid of? We want to get rid of hours. So if hours is on the bottom, hour is going to go on the top here. So 1 hour is equal to 3,600 seconds. So now we've got hours on the bottom, hours on the top. Now they cancel. Look at the only 2 units that remain. The only 2 units that remain, and that's why we write them every single time, are feet and seconds. And feet and seconds are what we were asking for. So now we just need to multiply. We multiply straight across on the top. So we're going to be left with feet on the top and seconds on the bottom. So on the top, we've got 60 times 5,280, and 60 times 5,280 is 316,800. So 316,800. And then on the bottom, of course, all we have is 3,600. So from there, we just need to do the division. So let's go to the calculator and let's do that division. So we have 316,800 feet, can't talk, and that's going to be divided by 3,600. So what we have here is a cheetah that is moving about 88 feet every second. So we've answered the question. At that rate, how many feet per second? So 60 miles per hour is 88 feet per second, and that is our answer. Okay, we're going to keep going. I'll move a little faster on the next one. The next one says, the top speed of a 747, and a 747 is just a passenger airliner. So a 747 is about 570 miles per hour. We want to convert this rate to kilometers per minute. So 570 miles per hour, and we're going to kilometers per minute. So write down what we're given. 570 miles per hour. There we go. What do we want to undo first? Let's undo the miles. Let's change miles to kilometers. So let's see. I've got on my index card that 1 mile is equal to 1.609 kilometers. So 1 mile, miles is on the top, then our mile has to go on the bottom, equals 1.609 kilometers. So we've got our miles ready to cancel now. And now we've got kilometers per hour, but we're not done yet because we want kilometers per minute. So the next thing we need to cancel are the hours. So hours are on the bottom here, therefore we need an hour on the top. An hour is equivalent to 60 minutes. Remember, these are unit multipliers. They're all equivalent to 1. Now hours cancel. What are we left with? Kilometers per minute, and that's what we want. So we're going to stop. Now we're going to multiply straight across. So what do we have? 570 times 1.609. That is 917.13 kilometers. Every 1 times 1 times 60 is 60 minutes. Now we just need to make that reduction. So 917.13 divided by 60 is 15.2855 kilometers every minute. That's pretty fast. That's a pretty fast plane. That's why we can fly across the country in about 6 hours. Even faster on land than the cheetah, we have the original Japanese bullet train called the Shinkansen. It cruised at a rate of approximately 184 feet per second. How fast is the train in miles per hour? So look at what we're given. My cat hears me talking about a cheetah. She must be insulted. So 184 feet per second. That's what we're given. We want the train speed in miles per hour. So we're going from feet per second to miles per hour. 184 feet per 1 second, and we want to get to miles per hour. So you make a plan. What do you want to undo first? I usually undo the length dimension first. So if we want to go from feet to miles, we want miles, so miles are going on the top. 1 mile, and of course, on my handy dandy conversion factors, I've got 1 mile is 5,280 feet. 5,280 feet. So now feet on the top, feet on the bottom, feet cancel. I've got miles per second. I don't want miles per second, I want miles per hour. Let's use our conversion chart again. We wrote it on the back. 1 hour is equal to 3,600 seconds. So for us to go to feet per second, we can dump that second and change it to hours. So 3,600 seconds is 1 hour. Seconds on the bottom, seconds on the top, seconds cancel. What's left? Miles over hours, which is what we want. We want miles per hour. So now we just need to multiply. So we multiply here. We've got 184 times 3,600. That is 662,400 miles. And on the bottom, our only unit that's left is hours. So 5,280 times 1. So 5,280 hours. So this is the fraction that we need to simplify, because this is not a good unit rate, because we want to know per 1 hour, which is why we divide. So 662,400 divided by 5,280 the bullet train on land going 125.45 miles per hour. So the bullet train is going twice as fast as the cheetah. And this was the original bullet train. When I was doing a little research for this problem, newer bullet trains on land go faster than 200 miles per hour in Japan. Next, the average swimming pool holds 15,000 gallons of water. If your garden hose can deliver 8 gallons of water every minute, how many hours will it take to fill the pool? So this is our last problem. We're trying to fill a swimming pool that holds 15,000 gallons of water. We just want to fill it, and we want to know how many hours is it going to take to do that. Well, our garden hose delivers 8 gallons of water every minute. So our given rate that we're working with here is 8 gallons every 1 minute. 8 gallons per minute. Every means the same thing as per there. So the first thing we need to do is, if we're trying to find out how many hours it's going to take, let's change this rate. If it's gallons per minute, let's change it to gallons per hour. So one quick unit multiplier here, because we've already got gallons. We don't want to change it. We just want to change the unit of time. And we want to go to hours. So 60 minutes is equal to 1 hour. Minutes on the bottom, minutes on the top. So what we've got here, 8 times 6 is 48. Add the 0. That's 480 gallons every hour. So because of that, you never want to leave the hose on in your backyard. That would waste a lot of water. So let's think about this. We want to fill the pool. The pool holds 15,000 gallons. We want to know how many hours. Well, we want to fill 15,000 gallons. And we're going to divide that by the number of gallons per hour. So 480 gallons per hour. So we're dividing because we want to know, well, how many hours is it going to take to actually fill this swimming pool if we already know how big the pool is. So this is a good reminder that 15,000 gallons divided by 480 gallons per hour, when we're dividing by a fraction, even though it's just made up of units, we're still going to change division by a fraction to multiplication by the reciprocal. So 15,000 gallons times 1 hour over 480 gallons. Gallons could cancel. We could have also done this one with a proportion, but we are almost done here because look at the only unit that's left, hours. The only unit that's left is the number of hours, and that's the unknown in this problem. So 15,000 divided by 480, 31.25, and once again, only unit that's left is hours. So if we have a standard 15,000 gallon swimming pool and a hose that delivers 8 gallons per minute, it's going to take 31.25 hours to fill it. That's more than a day. So that is diving deeper into dimensional analysis.